This is Lecture 9 Bivariate Regression. By the end of this lecture, you should be able to interpret a regression coefficient, interpret a significance test for a coefficient, interpret a constant in a regression analysis, interpret a significance test for a constant in a regression analysis, calculate an estimate from a regression equation, calculate the errors from a regression equation, interpret an R-squared and adjusted R-square, and know when to use an ordinary least squares regression to interpret the relationship between two variables. In the previous lecture, I showed you how to calculate a correlation coefficient between two variables. A correlation coefficient tells you the direction and magnitude of the relationship between two variables, but it does not distinguish between one variable being an independent variable and the other variable being the dependent variable. In addition, it does not tell us the specific impact of an independent variable on a dependent variable. Sometimes we want to know, as the independent variable changes by 1, by how much does the dependent variable change? In this lecture, I'm going to talk about ordinary least squares regression. Ordinary least squares regression tells you the specific strength of the relationship between an independent and dependent variable. It assumes that the independent variable has a linear effect on the dependent variable. In other words, it assumes that the effect of the independent variable on the dependent variable is the same across all values of the independent variable. Therefore, a change in the independent variable at small values of the independent variable and a change in the independent variable at higher values of the independent variable have the same effect on the dependent variable. Ordinary least squares regression also tells us by how much the dependent variable changes as the independent variable changes by 1. To illustrate the intuition behind calculating a regression analysis, I gathered data on the net migration of countries in 2010, the dependent variable, and the GDP per capita of those countries in 2009, the independent variable. I expected GDP per capita to have a positive effect on net migration, as in, as the GDP per capita increases, more people will migrate to the country than leave the country. I present the data in this scatter plot. When I run a regression on this data, the regression analysis creates a line that literally goes right through the middle of these observations. One way to formally represent a regression equation is to write y hat equals b hat times x plus a hat. Y hat is an estimate of the dependent variable. B hat is the coefficient slope or beta. X is the independent variable, and a hat is the constant y-intercept or alpha. Now imagine I tried to draw a line through the middle of these observations myself and tried to estimate the regression equation. The y-intercept a hat would be the value of y when the line passes through the y-axis. Next, the slope b hat is simply the change in y over the change in x. B hat is very important in the regression equation because it tells us whether the independent variable has a positive, negative, or neutral effect on the dependent variable. If the coefficient has a positive sign and is statistically different from 0, then the independent variable has a positive effect on the dependent variable. As the independent variable increases, the dependent variable increases. If the coefficient has a negative sign and is statistically different from 0, then the independent variable has a negative effect on the dependent variable. As the independent variable increases, the dependent variable decreases. If the coefficient is not statistically different from 0, then there is no evidence that the independent variable has an effect on the dependent variable. As the independent variable increases, the dependent variable stays the same. Last, the coefficient also tells us the specific effect that the independent variable has on the dependent variable. For example, if b hat equals positive 1.5, as the independent variable increases by 1, the dependent variable increases by 1.5. If, on the other hand, b hat equals negative 1.5, as the independent variable increases by 1, the dependent variable decreases by 1.5. Now that I have shown you the intuition behind a regression equation, I'm going to briefly show you how b hat and a hat are formally calculated. B hat is the sum of each x observation minus the mean of x times each y observation minus the mean of y, and that value divided by the sum of each x observation minus the mean of x squared. All this is really trying to calculate is whether each x deviates from its mean in a similar manner to its corresponding y deviating from its mean. This is similar to the correlation coefficient calculation. A hat is simply the mean of y minus b hat times the mean of x. Fortunately for you, I'm not going to ask you to calculate b hat and a hat in this course. I will cover that material in Political Science 398. Instead, I'm going to show you how to run and interpret a regression analysis in SPSS. For this course, we will let SPSS calculate our regression equation for us.